8.2, Slope Fields and Euler's Method, Part 2. So what we're going to talk about in this video is Euler's method for differential equations and trying to find what by Euler's method, and what we assume is how your calculators or computers are working through and trying to find the same procedure. So what we're going to do is we're going to be calculating solutions for differential equation by hand. So what Euler's method is saying, though, well, if we wanted to evaluate something here, and we'll call it u sub 0, and I want to try to then go off and find this curve by finding the next point that's on this curve, we can do it by, if we have the tangent line, which we know is slope, is the derivative. So we know slope is the derivative, and I'm going to write it up over here real quick. Slope is going to be now starting at 0 for this example, and then u sub 0 is my first y value, and we're going to multiply it by, or I'm not sorry, not multiply it yet, but what is it? It's going to be u sub 1 minus u sub 0, our y value. So I'm trying to get some point here, maybe we'll call u sub 1. And then I'm going to have that difference of y's over the differences in the t's. But in this case, I'm going to call it delta t. So what I want to do then, if I can, I'm going to draw another picture here using this idea that we have the change in the y's over the change in the delta t. So this part here should be my u sub 1 minus u sub 0. And then this should be my delta t, my changes in my t or independent variable. And we know that that's slope. We can do that. And then what if I want to go ahead and take this equation, but what if I try to take this and solve for u sub 1? If I took that and solved for u sub 1, I would get, multiplying both sides by the delta t. And then if I go ahead and add my u naught to both sides, I would get, let me erase that and put my u sub 1, I would get this equation. So all I did was took our definition of slope and solved for the next point, u sub 1. And then this is Euler's method. He's saying, well, if you can take the value of that function that we are calling a slope, then we should be able to get the next point closer. So then we could do this repeated over and over and over. We would take the line tangent to that point, trying to follow the curve, and we can get a series of points that may look like this, depending on where we want to look, so that we can have a bunch of these segmented lines. Oops, that didn't segment too well. And then we could say, oh, this is what the function would look like. That's the solution to the differential equation. So what we want to do then is apply this method over and over and over again. So here we have our procedure for Euler's method. So we want to choose a time step. Time step is what we call the delta t. How did we move in time? And a positive integer n, such that delta t equals t divided by n. So notice we have this t here, which is where we want to end up, and we're going to divide by some positive integer n. So this is t sub k, where k equals delta t, and we want to have positive integers and 0 for our k. So basically, we're going to always start with a u sub 0 equaling some number, and then we're going to be plugging into this formula, and we can keep computing. So we want to do this u sub k approximation to the exact solution. So we're going to go ahead and try some. Let's do, for example, Number 34. All right. So the book gives us a chart to fill in. So if I have this chart, let's start with 0, oops, 1, 2, and 3. So these are my K's I want to start with. And these are my T sub K's that I want to do next. So then I have, they're telling me 1, 1.25, 1.5, oops, and 1.75. So this is definitely given to us. They're telling us our delta T is going to be given from this information because I'm going to need delta T. Delta T in this case looks like it's going to be 0.25. That's our step, time step. And then we have how many we want to start with. We have K. Remember, we're going to use U sub K. So we have 0 will be our initial one, then 1, 2, and 3. Then the next thing we have to do then is they're saying in order to find our values, we got to find U sub K. And then we need to go ahead and definitely find what's the actual slope at those points. So this is our chart that we want to fill in. So then remember, our formula that we want to use is going to be U sub K, oops, start over, plus 1, U sub, let's do it over again, U sub K plus 1 is equal to U sub K plus F of T sub K U sub K times my delta T. So this is what we're saying. We can find the initial U sub K by our given information. And then we're going to use that to find slope. And then we're going to use that all that previous information and we can find the next U sub K using this formula. So they're saying, okay, if my given information is when T sub K equals 1, the Y equaled -1. If that's the case, my first U sub K, my initial one, U sub naught, is -1. Then I can use my T and my K to plug into my function. Notice this is really technically going to be my Y. When I plug in into my function, I really get -1 minus 1 or -2 is my slope. So that's fine. But now the trick is I've got to use Euler's formula here to find my next U sub K. So U sub 1, I need to plug in, and I'll do the work over here. To find U sub 1, I'm going to plug in U sub naught plus, I'm going to plug in what I found, which was my slope, or -2 times the delta T, which we said was 0.25. So we plug that in, and we should get that my next U sub 1 value should be a -1.5. Then I'm going to go ahead and plug in these two values into my function to find slope. That slope, when I plug it in, should be a -1.5 minus the 1.25, or a -2.75 is my slope. So I want to go ahead and find the next U sub K. So I'm going to go ahead and say, all right, U sub 2. I'm going to go ahead and use the previous U sub K, which would be -1.5. I'm going to go ahead and say plus the slope, which is a -2.75, times my dt, delta t, which is 0.25. When I calculate that, I get -3.688. Uh-oh. Wrong spot. Sorry, hold on. Wrong answer. When I plug and chug this one, I should get the negative 2.188. Then, using this, finding my slope, I want to go ahead and plug in negative 2.188 minus the 1.5. And this equals the negative 3.688. Finding the next u, I get u sub 3 is equal to the previous u, so u sub 2, which was negative 2.188, plus the slope, which is negative 3.688 times delta t. When I plug and chug this answer, I should get for the u sub 3, negative 3.109. And therefore, that's all they wanted us to fill in this box. So you notice how then we got to find these two pieces of information in order to find the next u sub k. All right, one more example for Euler's method. Here's a differential equation. Here is an initial value for our u sub naught, and then we have our delta t's given to us. And then all they want us to find is the first, we're going to use u sub naught as given to us, and they want us to find the next two, or u sub 1 and u sub 2. So that's all we're going to do. So if I'm going to go ahead and do that, I'm going to go ahead and say u sub naught is given to us when we plug in 0 into the function, or when it was, they're saying initial, we should have a value of 2. So we're going to use that 2 to plug in for our next Euler's method. So u sub 1. We're going to do u sub 0, or u naught, plus, and if we plug 2 back in, we would get a slope of 4 times the delta t. All right? So that one, we have it comes out as a value of 4. So now, to find u sub 2, that is my 4 is my previous u sub k, plus, I'm going to find slope by plugging that 4 into the differential equation. 4 times 2 is 8 times the dt. And when I get that answer, this is all they wanted really here, was these two u's. And that is Euler's method.